a lot of psychological issues that come into play around climate change, but one of the most basic and most important is that it's invisible. The carbon dioxide, the fundamental cause of this problem, is invisible.
Carbon in different chemical states gets redistributed in different parts of the planet. And this process of it moving through many different parts of the planet is called the carbon cycle. Since we care so much about carbon dioxide in the atmosphere, it's really important understanding the carbon cycle, because the carbon cycle impacts how much of that carbon dioxide gas actually ends up being in the atmosphere and for how long. But not only is it in different places in the planet, it also moves from one thing to the next. So it's difficult to come up with that coherent picture.
For scientists, the carbon cycle is the key to understanding Earth's future climate. How carbon moves, where it lingers, and for how long will determine how rapidly the planet warms. But it's hard to visualize because the carbon cycle is enormous and enormously complex, operating on scales ranging from tundra grasses photosynthesizing carbon to the sea floor locking up carbon in limestone. And it's also hard to measure, to track the carbon atoms moving through the sea, the forest, the atmosphere, the ice. Consider the Arctic, where a massive amount of carbon is locked up in the permafrost. It's a critical part of the carbon cycle, but its vastness and remoteness make it hard to grasp.
In Alaska, we have only one road goes to the north from Fairbanks. It's a pretty remote area generally, and because of that, not much of infrastructure. It's difficult to get in many places. And Alaska coverage by our network is not as bad as other places, especially in Siberia.
Unfortunately for that region of the world, we have very, very few measurements in the field. There are towers, they're oftentimes about 100, 200 feet tall, measure what's called a footprint. So let's say over a city block, they're measuring how much carbon is being emitted from that land. And there are only about 4, maybe 6 locations across all of northern Eurasia that are measuring these carbon fluxes. That really compromises our ability to understand how the system's behaving. We use models, climate models, to project what may happen in the future, but our confidence lacks when we don't have enough measurements in the field. We're likely underestimating the amount of warming we'll see because climate models don't take into account this release of carbon from thawing of permafrost.
The permafrost is at the heart of the Arctic carbon cycle, and it could be the key to Earth's future climate. It contains so much carbon, from thousands of years of plants decaying and then freezing in the soil, that as the Earth warms and microbes feast on the melting permafrost, releasing that carbon into the atmosphere as CO2, carbon dioxide, or CH4, the potent greenhouse gas methane, it's on such a massive scale that at some point in the future, the Arctic could tip from being a carbon sink, as it is now, to being a carbon source, accelerating global warming. But without adequate measurements to use in building climate models, scientists are uncertain when this shift will occur. And on top of that, there's the conceptual challenge for the public of understanding how microbes in soil can lead to carbon in air.
People do fairly well when there's a single step. If it warms, the glacier melts and that runs off water and the sea level rises. But it gets harder when we sort of say, well, when it warms, it might thaw the ground. That might change the microbial action and more methane will come out. That'll warm the climate. So that's too many steps, right? That's the problem with greenhouse gases. Can't see them, can't see where they come from. The magic of the tunnel clearly let people sort of see in some way the reality of a climate change process that otherwise is hard.
When you step inside the Arctic permafrost, you smell climate change. Here are 20,000-year-old grasses and the remains of horses and mammoth that walked the Pleistocene. Here are microbes digesting the soil. Here is ancient carbon being released into the atmosphere, warming the already warming Earth.
We're doing such a big experiment to the Earth system by burning so much fossil fuel that it's, of course, important to understand every aspect of the Earth system that we can. How the permafrost in Alaska or in Siberia is responding, how rainforests in the Amazon or in the Congo are going to respond as the Earth warms. But at the same time, this is fundamentally driven by our use of fossil fuels, and it's that we ultimately have to solve if we're going to fix this problem. None of the other things will matter if we don't solve that problem.